CCI, Crash Course Instrumentation presents EP number 77, Elementary Circuit Design number 3, Ground Isn't Magic, Safety versus Reference, Open, Hook plus Promise. Ground is not always the dirt, and it is not always 0 volts. Today you will learn the very simple difference between safety ground and reference ground, and how to measure without creating a short. Special thanks to Tony Coupalt and the open source community for the model materials that inspire this series. Section 1. 2 jobs that people call ground. Safety ground is a protection path to the earth, so fault current goes to the metal chassis and back to the source instead of through you. Reference ground is a measurement zero inside your circuit, like the negative terminal of a small direct current power supply. These 2 grounds can be connected together or kept separate on purpose, and that design choice changes your readings. Section 2. Safety ground, in plain English. Safety ground is the green or green-yellow wire that bonds every exposed metal part to the panel or chassis. A thick bonding strap or ground lug must touch bare metal, so scrape paint or use serrated washers to bite through coatings. A good panel shows low resistance from any door or backplate to the ground stud, which keeps a fault at near 0 voltage to touch. Never lift or defeat a safety ground on any tool or instrument. Section 3. Reference ground in plain English. Reference ground is the point your circuit calls 0 volts, so every other voltage is measured with respect to it. In low voltage control panels, this is often the negative of a 24-volt direct current supply. Reference ground may float above the earth by a small amount, so 2 different grounds in the same building can disagree by a tiny voltage. That small disagreement shows up as hum or noise if you tie everything together at random points. Section 4. 1 star point keeps things quiet. Pick one place to connect reference grounds together and call that the star point. Bond the safety ground directly to the chassis at its own stud, then tie the reference ground to the chassis only at the star point if your design requires it. Keep noisy returns, like motor drives, away from sensitive sensor returns, and meet them only at the star point. Use twisted pairs for sensors and land shields at one end, unless the device maker says otherwise. Section 5. Measuring without getting bit. A bench oscilloscope ground clip is normally bonded to earth through the power cord, so that clip behaves like a grounded wire. If you clip that lead to a hot point, you can create an instant short to ground and damage parts. When in doubt, start with a battery-powered handheld meter or a truly differential input that does not reference earth. Place shunt resistors or sense points on the side of the circuit that is close to ground potential so your meter's reference is safe. Never remove the ground pin from a power cord, and never use a cheater plug to float a scope. Section 6. 2 simple examples. Example 1. A small direct current supply feeds a lamp and a sensor. Call the negative terminal reference ground. Put your meter black lead on reference ground and probe the other points. Now your numbers make sense and you do not risk a short. Example 2. A metal-cased instrument that plugs into 120 volts alternating current. Its case is bonded to safety ground with the green wire. If you need to view a small sense resistor, place that resistor on the side that is near ground, often the neutral or the chassis referenced side, and measure with a differential tool or an isolated handheld meter. Only qualified people should open mains equipment. Section 7. A quick history note. Early telegraph systems used the earth itself as the return path to save copper wire, which is where the word ground became common. That history explains why many drawings still show a little rake symbol, even when the point is only a local reference and not the dirt. Section 8. Common mistakes and easy fixes. Assuming any point labeled GND is safe to touch, it could be only a reference node. Clipping a grounded scope lead to a live conductor, which creates a short. Tying shields at both ends by default and building a ground loop that injects hum. Letting paint or corrosion sit under a safety bond and then trusting that bond. Fix 1. Treat every ground label as a question and ask, safety or reference? before you connect. Fix 2. Use a continuity check to prove the case is bonded to safety ground before you power up. Fix 3. Use a star point and one-end shield practice unless the device maker says otherwise. Fix 4. Keep noisy returns and sensitive returns physically separated until the star point. In Section 9, 10-second recap. Safety ground protects people and equipment. Reference ground sets 0 for your measurements. 1 star point and careful measuring stop noise and prevent shorts. Outro, CTA. If this helped, tap like, subscribe, and share with a classmate or coworker who is learning to measure safely. Thank you again to Tony Coupalt and the open source community for freely sharing the core ideas we teach.